I'm going to go through some circle theorems. Now, I'm not going to teach you what the circle theorems are. There'll be other videos online you can watch which will tell you how to go through them. I'm just going to focus on how we apply it and how we answer questions on an exam paper. So, the first thing we're going to look at, question 1, it says A, B, C and D are points on the circumference of a circle. So, I know that these values here, A, B, C and D, are all on the circumference. I'm told the angle of ABD and BAC and they're given to me. The first thing I'm asked to is find the size of the angle ACD. So in order to know what that is, I'm looking for the angle which starts at A, goes to C, and then comes down to D. So hopefully, from reading this notation, I should know I'm looking for this angle here. Okay, so how do I do this? Well, this is just applying one circle theorem, but you can see it's 3 marks, so I'm going to have to give a reason for my answer. Hopefully, you can see that if I draw a line across here, we'd call that a chord. I have got angles which are in the same segment. So the angle ABD is equal to angle ACD, so therefore this angle must be 54, and I would say angle, and I believe it was ABD, is equal to angle, and I would call this ACD, as angles in the same segment are equal. And this would be sufficient to get all 3 marks. So I've stated my rule, I've used explicitly the notation that they've chosen to clearly outline it, and then I've gone ahead and just written the actual circle theorem which I've followed. So that would be the sort of approach I would be looking at to get 3 marks. Looking at the next question, A, B, C and D are points on the circumference of a circle. So straight away, I'm thinking cyclic quadrilateral. Straight away, it wouldn't be so definitive. Angle AOC is 168, and angle AOC is at the centre, so I know that there's only one rule I can use there. Work out size of angle ADC, you must give reasons for your working. And I'm looking here, I'm seeing 4 marks, so that means I'm going to have 2 angles that I need to work out and 2 rules. So, let's have a look. Well, here we can see AOC, and if we also look, I've got ABC, angle at the centre is twice that of the angle subtended at the circumference. So I know straight away that ADC is equal to 2 lots of ABC. So if it's 168, let me just correct that, 168, that's going to be equal to 2 lots of ABC. So therefore ABC, lovely, is going to be equal to 84. Now that's not sufficient because I've not written down the reason why. So I'm just going to finish that with angle at the centre is twice the angle at the circumference. And once I've done that, I'm going to just annotate on that this is now, what did I say, it was 84, apologies, 84. Okay, so carrying on, I'm just going to go out my highlighted sections. I'm now thinking back to this first point they told me, A, B, C, D are points of the circumference. So, A, B, C, D. I have got a cyclic quadrilateral. You should know that opposite angles in a cyclic quadrilateral sum to 180. So, ABC plus ADC is equal to 180. So 84, and if I take 180 from it, 96. So ADC is equal to 96. And again, I need the reason. Opposite angles in cyclic quad sum to 180. Okay, lovely. Now, the next one I want to look at is question 4. So it's a little bit different. We're told B and C are points on the circle, centre O, AB and AC are tangents to the circle, and angle BOC is equal to 130. So I've got a lot I need to actually write in. So I want to know that I've told that angle BOC is 130. So I'm just going to annotate that in. I've got B to O, O to C, and we should know that these are radii, so I'm just going to draw them on, and now let's think about it. So, one rule straight away, angle and a tangent sum to have a meet at 90 degrees, sorry. So an angle between a tangent and a radius is 90. So I'm going to write this on by saying ABO is equal to ACO, which is equal to 90. And I'm going to state my rule because it's 4 marks. Angles between a tangent and a radii are 90. Lovely. Work out a size of BAO. So BAO looks like this. So hopefully you can see the line that O to A is going to split this larger quadrilateral in half. If this is 130, that should mean that this angle here, which is in red, is going to be half of 130, which is 65. I've got a triangle, I've got an angle of 90, I've got an angle of 65. Therefore, I know that A or BAO is going to be equal to 90, 180, take away 90, take away 65, which should give me 25. 25, and that's because angles in a triangle add up to 180. So make sure I write that in. Angles in triangle sum equals 180. Okay, lovely. One more question I want to look through, but hopefully you can see my thought process as I'm going through this. Looking at question 6. Now this is more of a proof question. So we've got given a circle. R and S are 2 points in the circle, centre of O. T and S is a tangent of a circle. So straight away, reading that, I've got 90 degrees here. I know I'm going to be using that tangent and a radius meet at 90. Okay. R and S are 2 points of a circle. I know that this, therefore, are both radii, so they're going to be both the same length. Prove that. Give that RST is equal to x, which I can see on the diagram, really helpful. Prove that ROS is equal to 2x, so ROS. So I'm looking for this angle here. And I want to prove that that is equal to 2s. So, first thing we should see, hopefully, just isolating this little section, I've got an x and I've got a gap. However, I know the total is 90. So, using the fact that a radii, a radius and a tangent meet at 90, I can say that this angle here, let's call it alpha. Alpha is equal to 90 take away x. Perfect, I've got this idea now. It's an isosceles triangle, so this is also alpha at the top. So therefore, and I'm going to write this in, isosceles triangles have equal base angles. So I know that those two angles are both 90 take away x. So if I'm thinking about the big triangle, I know that ROS plus 2 alpha has to equal to 180. Because it's just a triangle, they add up to 180. So the angle ROS plus, and 2 lots of 90 take away x is equal to 180. Again, ROS plus 180 take away 2x is equal to 180. So from there, it's very clear that ROS must be equal to 2x. Now, that is for reasons that I've used. I've used radius and a tangent meet at 90, and I've used isosceles triangles of equal base angles, and just a little bit of solving. Hopefully you found this useful. If you prefer these type of videos where I'm going through questions rather than explicitly teaching, please let me know. Thank you, and I'll see you in the next one.